So for this one, again, you look at the square root and you notice that the square root function, the square root of 1 minus x squared, that looks very similar to the derivative of arc sine. And so what we're going to have here is, if you're looking at your arc sine, again, you're trying to match it up, you want it to look like du square root of a squared minus u squared. So if you look at your current integral, where you have dx square root of 1 minus x squared, you'll see that your a is equal to 1, your u is equal to x, du is equal to dx. So you have a one-to-one relationship with everything plugged in there. So then you can plug in your formula, and for arc sine, that's the one that you do not have to multiply by 1 over a. It's just going to be sine inverse of u over a plus c. So for this one, you will say that it's equal to sine inverse, your u is equal to x over your a, which is 1. And then you'll notice here that we can't put the plus c because we do in fact have bounds. We have the negative 1/2 to 1/2. So we're going to have to plug in those bounds. And when we plug in those bounds, it will be the upper bound minus the lower bound. So we will be looking at sine inverse of 1/2 minus sine inverse of negative 1/2. Now again, when you're talking about inverse trig functions, you're really asking yourself here, what angle is going to give us 1/2? So you're only looking in quadrant 1 and quadrant 4. So you're only looking in square or negative pi over 2 to pi over 2 for your sine inverse function. So you say to yourself, okay, where is your y coordinate equal to 1/2? And that is going to happen at pi over 6, where your y coordinate is equal to 1/2. And then minus, and for your sine inverse of negative 1/2, that is where you are going to ask yourself, where is your angle, sine of theta of an angle, equal to negative 1/2? Now again, you can only look in quadrant 1 and quadrant 4. So when you look in quadrant 1 and quadrant 4, the reference angle is going to be the same. It's just now it's going to happen at 11 pi over 6. The problem is 11 pi over 6 is not in this interval. So what we have to do with the 11 pi over 6 is we have to subtract 2 pi off. So it'll be 11 pi over 6 minus 12 pi over 6, and that gives us negative pi over 6. And that negative pi over 6 angle does lie in that interval. So we have our negative sign coming down from the upper minus the lower, and then this sine theta equal to negative 1/2 is the angle negative pi over 6. So I know that's a lot of work. You're kind of going off to the side here trying to figure out your reference angle, but at the end of the day, you have pi over 6 minus another pi over negative pi over 6. So that's going to give you 2 pi over 6, which gives you pi over 3 as your answer.